If an odometer measurement with estimated uncertainty is 121.72 miles plus or minus 0.05 miles, but the actual trip distance is 123.5 miles, is this measurement accurate, precise, or both? So maybe if we think about this in terms of the analogy I had up here, the archery analogy, and we could also go back to the key concepts page and look at some of the things that were stated there. But the way I would think about it here is I would say, because like, what is the correct value, right? I think in the key concepts page it referenced the correct value. Like something is accurate, I guess, if it's close to the correct value, right? Or if its average value is close to the correct value, but it's precise if it doesn't vary very much. So which one of these does this fall into? Well, again, that's with all those words, it's maybe a little hard to just answer that right off the bat. But if I think about it this way, if the 123.5 miles, if I say that that is kind of associated maybe with the bullseye. How do you write bullseye? I think you can write as one word, right? Anyways, don't tell an English teacher if you can't that I did that. Um, okay, so I'm going to think of that as a bullseye because that's the bullseye kind of represented the correct value in this analogy, right? But then when I look at the numbers that are given to me, it says with estimated uncertainty. So that's kind of language, or estimated error, it turns out is also okay. We'll be using language like that in the lab portion of this class quite a bit. And one way to think about this is that this is the average value that happened or could happen. If it's an odometer measurement, though, typically what we wind up doing in our lab as well is like, when I say average value, if you've taken a stats class, you might think, well, does that mean I did the trip like 10 or 15 or 20 times? I measured all 10, 20, or 15 or whatever values, and I averaged over those, and I found that somehow maybe I calculate a standard deviation or something like that. That'd be one way to do it, but it turns out it's okay to just estimate an uncertainty based on what you expect that variance to be based on how accurate you think, or how, maybe I should have said there, how precise that instrument should be. So really this, like I look at this number as a measure of precision. So maybe I'll write that here, the plus or minus 0.05. Actually, maybe the plus or minus, maybe I don't need that. I might be misleading people if I put that there. So I'm going to go ahead and erase that because really you don't need the plus or minus if you just say, hey, here's my uncertainty. 0.05 miles is the uncertainty, but what I'm going to associate that with is that is going to be associated with the amount of precision. And my spelling's not very precise apparently. Anyways, amount of precision. Fix that a little bit more. Is that a precise enough fix? Anyway, the smaller that number is, the more precise we're talking about. Now, what might be the accuracy, sometimes we'll also call this the discrepancy, is if I look at like the difference between these two numbers. Here's the bullseye, right? 123.5 is the bullseye. Maybe I can skip writing units for a second here if everyone's cool with that. Sometimes that's not cool in physics class, but maybe for this example it's okay. I'm just going to take the difference between these two things. And, oh shoot, I want to grab my calculator. Now, let me see. I think that's like 1 point. Oh, I wish I had an audience to help me out right now. Let me see. 1.78. Did I get that right? I'll check that later. All right. So this may be, I call this a discrepancy, but you could also associate this perhaps with accuracy or perhaps inaccuracy. In other words, how far apart were these two numbers? And I'm looking at this and seeing like, hey, this is a lot bigger than this number that I associated with the precision. So when it says here, is this measurement accurate, precise, or both, I'm inclined to say it's precise but not accurate. In other words, I think it looks like this because if you thought about like a cluster representing this plus or minus 0.05 miles, that would be a very tight cluster relative to how far this average value is from the correct value. So hence, again, this picture right here, I think is what's being described by these numbers. So hence my final answer is it is precise but not accurate. So there it says it's precise, assuming the estimated error is based on typical measurement variability of this odometer, but it's definitely not accurate.